This is Chapter 5, Algebra 2. We're going to do Section 2. These are properties of parabolas, and you should have your handout there. You're going to fill in these boxes. So, yesterday we talked about how you graph parabolas using a table. We also talked about using our calculator. And we also talked about when it's in vertex form, how do we graph it, and how do we move it or transform it. So, what we're going to do this time is we're going to introduce what we call standard form. Standard form looks like this. You've seen it before. It stands for ax squared plus bx plus c, and it has to be in that order. You'll notice that the highest exponent is first. So because we're talking about a quadratic, we're going to put x squared with some sort of coefficient in front of there. Okay, remember, a is going to be represented by a number, and as well as b and c. So let's start by how we evaluate these properties. We're going to start with whether the parabola opens up or down. This is simply by evaluating a. Okay, if a is positive, so you're looking at the front or the first number there, the first coefficient. If it's positive, it opens up. Obviously, if it's negative, it opens down. Okay, the next thing that we're going to do is we're going to find what we call the axis of symmetry. Remember yesterday when we were graphing them and we watched that video, we talked about the line of symmetry. It's just the center line of the parabola. It's the place that cuts the parabola in half. And this is just a formula that you have to memorize. To find the axis of symmetry, you use the formula x equals negative b, that matches this point, over 2 times a, which matches this number. We're going to use an example of this in just a minute. To find the vertex, you're going to take the x coordinate here and you're going to plug it in to the function. So if you plug in this x value, whatever number you get into this function, you'll get the y value of your vertex. So we say the vertex is represented by the axis of symmetry, the x that we found here, put that there, and the y that comes out of it after you plug it into the machine. The y-intercept is the easiest one of all. It's represented by c. The y-intercept is always whatever is right here behind the plus sign. Okay, let's jump into an example of these. Let's start by recognizing that if we are finding the formula, the properties, excuse me, for y equals x squared minus 2x minus 3, we can graph this function using the properties. So the first thing let's do is let's evaluate whether it opens up or down. We can tell that since this is a positive number right here that our graph's going to open up. Make sure you write down the things that I say, not just the things that I write down. The first step is to find the axis of symmetry. Remember, the formula for the axis of symmetry is x equals negative b over 2a. In our example here, b is a negative 2, so we say negative, negative 2. A is 1, so we say over 2a, and we get a positive 2 over 2, or 1. So our axis of symmetry, if we wanted to graph it, we could sketch this real quick, and I'm going to show you piece by piece how you graph it. We would just make a dotted line at x equals 1. So you know that your vertex is going to lie somewhere along this line. So we're going to take this x equals 1, and we're going to plug it into our machine, which is over here. We're going to plug it in and see what comes out when we plug it in. So in step 2, to find the vertex, we're going to plug in or substitute x equals 1 into the equation. And you can see what happens. We're going to plug 1 in using parentheses. Remember, that's what you do when you're plugging in. Square the 1, minus 2 times 1, minus 3. When we do all of that here, we get a negative 4. So this is the y value when our x value was 1. So we say that our vertex lies at 1, which matches here and here, comma negative 4, which matches here. So how do we graph this? This is just a point. So we take our axis of symmetry at x equals 1 and we plot the point 1, 1, 2, 3, 4. 1, negative 4, and we plot that point. Remember, we already know that our graph opens up. In the next step, step 3, all we have to do is plot the y-intercept. Remember, you can get the y-intercept simply by looking at c. Our c is negative 3, so we're going to plot the y-intercept at negative 3 along the y-axis. Now this next step, step 4, says mirror the y-intercept. Well, if this is your line of symmetry, and this is a point on a parabola that's U-shaped, you can see that I can put that other green dot over here. I can mirror this axis of symmetry using the y-intercept. And now I can get a basic sketch of my graph just using these 3 points. We're going to add more to it later on in the chapter because we're going to be able to find the x-intercepts pretty simply. But for this example, you should have a graph that looks like this. Now, the only other question that you're going to have to do when you do your exercises tomorrow is there a minimum or a maximum? That's the first question. So does this function right here have a minimum or a maximum? And you can see that it does have a low point. Right here is its minimum. What is the value of that minimum? Where is it? Where does it lie? It lies at y equals -4. And if you're paying attention, I want you to try to come prepared tomorrow with, tell me what that matches. Where in the problem does this y equals -4 match? It's the minimum, but it's also something else. Okay, I'll see you tomorrow. Have a great night.